give you a quick walkthrough of the Enterprise AI Capability Hub and show how it helps an organization manage AI capabilities as governed enterprise assets. We begin on the main dashboard. At the top, we can switch between light and dark themes. The dashboard gives us two immediate views. The first is the overall operational status of the AI capability portfolio. Here, we can see that the organization currently has registered capabilities. How many are published, deprecated? The second view highlights items that require attention. Capabilities are waiting for security review, and 3 are currently failing validation. This allows governance teams to focus on exceptions rather than manually checking every capability. As we move a bit up at the landing space, we can see that the hub is not limited to agents or prompt files. It manages the broader AI capability ecosystem. This includes skills and SKILL.md specifications, agents and workflows, MCP tools and enterprise APIs, models and prompts, and approved knowledge sources used for retrieval. The objective is to provide one enterprise view across all these components. Now, let us open a specific capability, the REST API generator. This capability helps developers generate a standard REST API based on approved specifications and enterprise patterns. On the details page, we can see its purpose, owner, current version, lifecycle status, risk classification, and approval state. Let us open the Steps tab. Here we can see the complete execution flow. It starts with the user prompt. The system then identifies the intent, loads the relevant skill.md instructions, parses the open API specification, generates the domain and persistence models, creates the application scaffold, and finally emits an audit event. This visual flow is important because it explains what the capability does without requiring someone to read the underlying implementation. Next, let us open the Usage tab. This section explains how developers can use the capability. We can see example natural language requests, such as asking the system to generate an API from a specification. We can also see command line options, SDK examples, and HTTP invocation patterns. The prerequisites are documented as well, including the required runtime environment and the MCP servers that must be available. This means the capability is not only registered, it is ready to be discovered, understood, and reused by other teams. Now, let us look at the reusable capabilities section. The REST API generator does not need to implement everything itself. It can reuse approved components for validation, documentation, compliance checking, or architecture standards. The related capabilities view also shows its dependencies. For example, it may depend on an approved functional design capability and delegate compliance validation to a separate compliance review capability. This is where the hub starts moving beyond a simple catalog. It shows how capabilities are composed. Let us now look at governance and lifecycle management. I will open the Tech Debt Tracker capability. This is version 0.9 and it is currently under review for retirement. At the top, we can see a clear sunset notice. The notice explains why the capability should be retired. The current version relies heavily on regular expression heuristics. It produces approximately 40% false positives and requires significant maintenance effort. The notice also explains the risk of keeping it active and provides a migration path to version 1.0. This is important because deprecation should never mean simply deleting a file. The organization needs to understand why the capability is being retired, which consumers are affected, and what they should migrate to. From here, we can propose an update or deprecate the capability. The owner can modify the sunset remarks, propose the next version, and submit the change for approval. The hub, therefore, maintains lifecycle evidence from creation through retirement. Now, let us move to the drafts workspace. This is where a developer or capability author can create or extend a capability. The process is divided into 5 steps. First, the author can start with a blank capability or fork an existing approved capability. Forking is useful when a team wants to extend an established pattern rather than rebuilding it from the beginning. The second step is the interactive editor. On the left, we have the capability file structure. This may include the SKILL.md file, validation scripts, reference documents, and supporting assets. In the center, the author edits the capability. On the right, the system provides a live preview of the metadata and documentation. This helps the author see how the capability will appear when it is published. The third step is structural validation. The hub automatically checks the capability metadata, naming conventions, description quality, declared dependencies, and the integrity of scripts and references. These checks prevent basic issues from reaching the approval stage. The fourth step is behavioral testing. The trigger test confirms that the capability activates for the correct request. The false trigger test confirms that it does not activate for unrelated requests. Input validation checks how it responds when required information is missing. The determinism check evaluates whether repeated executions remain within acceptable behavioral limits. This is a critical distinction. We are not only checking whether the files are valid, we are checking whether the capability behaves as intended. Once the tests are complete, the author receives a validation score and can submit the capability to the approval queue. The approval team can then review the same evidence rather than relying only on written claims from the author. Finally, let us raise a new banking capability. Here, the author starts by defining the business purpose and intended users. The next step maps the capability to an appropriate banking domain. For example, this could be payments, core banking, AML transaction screening, or party reference data. This makes it easier to apply the right ownership, risk controls, and domain standards. For this demonstration, I will load the AML example. The form is automatically populated with bank-safe sample values. We can then define the intended deployment target. For an on-premise environment, the capability may be published through an enterprise repository and deployed on OpenShift. For a cloud-based AI environment, it may target an approved cloud AI platform. The hub is not tied to one runtime. Its role is to govern the capability consistently, regardless of where it is deployed. When we submit the request, the hub generates the proposed capability package. We can see the skill.md specification supporting scripts, references, and assets in a linked file structure. The capability is not immediately treated as production ready. It enters the defined lifecycle for validation, testing, security review, and approval. That completes the walkthrough. What we have seen is more than a repository of AI files. The Enterprise AI Capability Hub gives the organization a control plane for discovering, composing, validating, approving, deploying, operating, and retiring AI capabilities. It creates visibility across skills, agents, tools, models, knowledge sources, and dependencies. Most importantly, it allows teams to innovate without losing enterprise control. The real measure of AI maturity is not how many agents an organization has created. It is how safely those capabilities can be reused, governed, changed, and improved across the enterprise.